Today we are going to be talking about biconditional statements here. Now, a biconditional statement, it needs both the converse and the actual conditional statement. All right, so something that's important about a biconditional statement is that both the converse and conditional need to be true. And that's to write your biconditional. Now, typically when you're writing a biconditional, a conditional is an if-then. And I keep track, by the way, of which one is which on a sticky note that I keep for myself as well. So if you want to do that, that's a good idea as well. And a conditional, you remember, okay, it's your hypothesis. If your hypothesis, so if P, then Q, your conclusion. You'll want to remember that P's are used as your hypothesis, and Q's are used for your conclusion. Now, why those two letters? I will let you figure that one out because that's been that way for quite some time now. All right, so we are going to make sure that when we're writing a biconditional statement, that both the conditional and the converse here, that both of these are true. All right, and when we're writing them, what we're going to end up doing is we want to make sure to use this phrase. It's a statement, and it contains the phrase, if and only if. Pretty much both sides have to be true. If you're ever writing this, it looks like this. It's got a double arrow. So it's saying that both the converse has to be true and the actual conditional statement. So both angles of it, both sides of it, sorry. All right, now something super important to note here. Definitions, they can always be written as biconditional statements. And that is something that you cannot break. So for the next ones, what we're going to do is we're going to start practicing a couple of them. All right, so first you have to write the converse of each statement, of each true if-then statement. And I'm telling you that these are true. There we go. Now, if the converse is also true, then combine the statements to write a true biconditional. All right, so let's first go ahead and write our converse. I'm going to write our converse in the same colors as I was doing yesterday. So our converse right here is going to be in purple. And if you'll look at our conditional right here, if an angle measures greater than 90 degrees and less than 90, this part right here is our hypothesis, which is our p-value. And then this part right here, then it is acute. It is acute is our conclusion. All right, for your converse, remember, we swap it. We go Q, then P. A way that helps me remember that for converse is it's change order. All right, so now we're going to write we're going to flip our original conditional, and it's going to be if an angle is acute, then it measures greater than 90, oh, sorry, greater than 0 and less than 90. And you have to think about that. If an angle is acute, then it measures greater than 0 and less than 90 degrees. Well, that is a true statement. And because, check, this is true, the entire converse is true here, then we can now write our biconditional, right? And our biconditional, remember, is right here. It's going to be an if and only if situation, and both sides of this have to be true. So the way we would write this is an angle is acute if and only if it measures greater than 0 degrees and less than 90 degrees. And now notice I just used the converse, and all I did was I removed this if right here, and I replaced the than with if and only if. That's it. Now, you can do it with the original conditional as well. So let's go ahead and do another one. If two angles are complementary, then the sum of their measures is 90 degrees. So let's work on our converse first, which means we're going to change the order, and it's going to become QP of the original. So if the sum of two angles is 90 degrees, then the two angles are complementary. Well, that is a true statement. If two angles add up to be 90, then we consider them complementary. And the first one was also true, or actual conditional. If they are complementary, then they're adding up to be 90 degrees. So, because this one is also true, yay! Now we can write our biconditional. So you can write it again using your original conditional statement. Two angles are complementary if and only if. Notice I'm replacing the then part of our conditional statement, and I'm replacing it with if and only if. And I keep going like normal. And if you're trying to keep up and you're like, I don't see it, well, let me go ahead and highlight the original hypothesis right here. Two angles are complementary. And in our biconditional, two angles are complementary. There's our hypothesis, there's our P. All right, then we also had our Q right here. It says the sum of their measures is 90 degrees. The sum of their measures is 90 degrees. And I could have written it the other way, which is the sum of two angles is 90 degrees if and only if the two angles are complementary. You could have written that way, and that would still be an appropriate biconditional statement. All right, let's do this next one. So let's do our converse of this true conditional statement. If a number is an integer, then it is rational. Well, yeah, an integer is part of the rational number system and part of the real number system. And rational numbers include like fractions and decimals, whereas integers, they're like -1, -2, not the in-betweens. Rationals include that. So, your converse We're going to swap it. We're going to swap our original conclusion with our hypothesis, and it's going to become if a number is rational, then it is an integer. Well, wait a second, that's not true, because here's a counterexample for that. The counterexample for a number being rational and it being not an integer is 3/4 or 0.25 or negative 0.376. Those are not integers. They're not integers. They're rational numbers, but they're not integers. Therefore, this isn't true, so you can't have a biconditional. Remember, both your converse and your conditional have to be true. So I'm writing a note here so I remember. Did I forget this? No. What I did is that my biconditional, the converse is false, so that's why I couldn't write it. All right. So now let's go ahead and do this one. If a figure is a quadrilateral, then it is a polygon with 4 sides. So I'm going to grab it. So it's a quadrilateral. That's my hypothesis. And then my conclusion, polygon with 4 sides. All right, so let's go ahead and write our converse. If a figure is a polygon, remember we're swapping our Q's and our P's, with 4 sides, then it is a quadrilateral. Well, that is a true statement. So because this is a true statement, what we can do is we can go ahead and write that as a biconditional. Yay! Unlike C, which was nasty, rude. So here's our biconditional. A figure is a quadrilateral if and only if it is a polygon with 4 sides. All right, so this is your basics on biconditionals. If you're in on level, then I want you to stop watching. Listen, I want you to stop watching at this point. If you're pre-AP, keep going, because these are some extra practice problems that you can use. If you're on level, you're welcome to watch, but you don't have to. All right, so for these next two, what I'm going to have you do is I'm giving you the biconditional statement here. And we are going to end up writing it as a conditional statement and its converse. Which, if you've noticed, all we're doing is we're going to break it up, kind of like what we saw in part B, right? It's just flipping it and rewriting it with a different set of words and connectors. So, 2 angles are adjacent, okay? If and only if, there's our key word for biconditionals, they share a common vertex and a common side. So, how you could write this then, for your conditional, is if 2 angles are adjacent, then they share a common vertex and a common side. All right, well, awesome. Now we have to write our converse. All right, so we are just going to swap our P's and our Q's, and now we're going to make it if two angles share a common vertex and a common side, then the two angles are adjacent. All right, now pre-P, here's what I want you guys to do. You are going to do part B on your own, and you are going to submit it with your work for today. So tell me your conditional statement. I want both. I want your conditional and I want your converse. All right, you can split it up. Look for this keyword right here, if and only if. That's what separates between your hypothesis and your conclusion. And those of you that are wondering, what if I wrote it backwards? What if I write it as my this is my converse right here, and this is my conditional. Well, and this, and that this part right here is my conditional. Well, you can do that. And that's okay. It only is the case for biconditionals. So thanks for watching. I look forward to seeing your answers.